Section 1.6, to identify angles in special angle relations and to apply the angle addition postulate. Defining an angle. An angle is formed by two rays with the same endpoint. So we could draw an angle. We have two rays. They have a common endpoint. We can label the ray AB and another one AC. Therefore, I have an angle, and I can call that angle BAC. AB is a side of the angle, and ray AC is a side of the angle. Point A is called the vertex of the angle. And when I identify the name of the angle, I must always use the vertex as the middle letter. Therefore, I have another way I could name this, and I could name this angle as CAB. Now I've identified this angle two different ways, but in both situations, letter A, or the vertex of the angle, is always in the middle. There are two other ways to name an angle. Since my angle is all by itself, there are no other angles associated to vertex A, I could actually name this angle A, or name it just by its vertex. I can only do that if there is one angle associated with the vertex point. Here, that's the situation, so I can name that angle A. I also could put a number inside of the angle. Then I could identify the angle as angle 1. These are the ways that we can identify angles. On this slide, they want us to name the angle four different ways. Here, I have an angle with a vertex of Y, and its sides are ray YX and ray YZ. I can name the angles several different ways. First, XYZ. The vertex is in the middle again. Also, ZYX. Again, the vertex is in the middle. Since this angle is all by itself, in other words, one angle associated with the vertex of Y, I can name that by its vertex, therefore, angle Y. I also could put a number associated to the angle inside of it and call this angle 1. Using this diagram, they want us to name three different angles. I am given a vertex angle of D. Therefore, I need to use that when naming the angles. The first one I'll identify is angle ADB. I also could put a number inside of that angle and call that angle 1. Another angle, angle BDC. Again, I could put a number inside of that angle and call that angle 2. In either case, I have used D as my vertex in the middle of identifying those angles. My third angle is the larger angle, which makes up both angle 1 and angle 2, which is angle ADC. Again, using D as the middle point to identify that angle. Also understand that I cannot use point D by itself to identify either of these angles. Point D makes up three angles, of angle 1, of angle 2, and angle ADC. The only time that I can identify an angle by its vertex alone is when there is one angle associated to that vertex. Here, point D is the vertex of three different angles. On the next slide, they want us to name the sides and the vertex of angle PQR. From previous slides, we know that the middle letter must be the vertex of the angle. Therefore, the vertex is point Q. Therefore, I know that the sides of the angle are made up of the rays. And the rays always start with the vertex. So my rays are QR and QP. Therefore, as long as I have the name of the angle, I do not have to see the angle to be able to name the vertex and the sides of that angle. During this geometry course, we're going to measure angles in terms of degrees. And when we do that, we need to use the protractor postulate. Let's read through. We want to let ray OA, which is located here on the protractor, and ray OB be opposite rays. Therefore, that means we know that O is between A and B, and they are collinear. Also, we know that ray OA and ray OB and all the rays with endpoints at point O that can be drawn on one side of the line of AB, paired with the real number line from 0 to 180, in such a way that OA is paired with 0 and OB is paired with 180. When this occurs, we know ray OC is paired with X here. That's the value that we find on the protractor. And OD is paired with Y, also the value on the protractor. Then the measure of COD is equal to the absolute value of X minus Y. In other words, we can determine the measure of this angle by subtracting the measure of this angle from the measure of that angle, and then taking the absolute value. Let's do some practice using the protractor postulate. Here, I have my line AB in opposite rays of OA and OB. Here, I'm going to have point C on the light blue ray and point D somewhere on the dark blue ray. And what they're saying is, if I measure from OA to OC, this measure turns out to be 50 degrees. That would be my value for X. And then counting from OA to OD, a point here, my value of this angle would be 140 degrees. Therefore, 50 minus 40 is going to give me a negative 90, but the absolute value of that would be 90 degrees. Let's take a look at one more example. Let's say I move OC to 30 degrees, but leave OD still at 140. Then, using the protractor postulate would mean I find the value of X, measuring from OA, this is going to be 30 degrees, minus, still measuring from OA to OD, still at 140, 30 minus 140 is going to give me a negative 110. The absolute value is 110 degrees. This is the measure of angle COD. Classifying angles by the measure of the angle. Acute angles have a degree measure that is less than 90 degrees, but later than 0 degrees. Therefore, it is a small angle. A right angle has a degree measure of 90 degrees and can be represented with a symbol of a box in the corner of the angle to represent 90 degrees. An obtuse angle has a degree measure of less than 180 degrees, but greater than 90 degrees. Therefore, it is the large angle. And we also know a straight angle is any straight line. So 3 collinear points would determine a straight line, therefore would have a degree measure of 180 degrees. From previous sections, we know that we can have congruent segments. Now we can define congruent angles. These are angles with the same measure. Here, I'm given the measure of angle ABC to equal 38 degrees. I'm also given the measure of angle XYZ to equal 38 degrees. Since these two angles have the same measure, they are congruent. Therefore, angle ABC is congruent to angle XYZ. And when I show congruency, I use the symbol for congruency, and I can eliminate the M, which means measure.